Before 2017, we processed language like we read it, one word at a time. Recurrent neural networks, LSTMs, GRUs. They all had the same fatal flaw, sequential dependency. To understand word 100, you had to process words 1 through 99 first. This created two devastating problems. First, vanishing gradients. By the time you backpropagate through a long sequence, your signal has decayed to noise. Second, you cannot parallelize. Every word waits for the previous one. Training on massive datasets? Forget it. Your GPU sits idle while computations queue up single file. The architecture that powers every modern AI assistant was born from a simple question: what if position did not require sequence? In 2017, a Google paper dropped with possibly the most confident title in machine learning history, "Attention is all you need." The core insight was radical. Instead of processing sequentially, let every word look at every other word simultaneously. The attention mechanism computes a relevance score between all token pairs. When you read, "The cat sat on the mat because it was tired," how does the model know it refers to cat and not mat? Attention. It learns to assign high weights between related tokens regardless of distance. Suddenly, a word at position 1 can directly influence position 1000. No degradation, no weighting, just pure parallel pattern matching. Here is where the magic happens. Every token gets transformed into 3 vectors: query, key, and value. Think of it like a search engine. The query asks, "What information am I looking for?" The key says, "Here is what I contain." The value holds, "Here is my actual content." For each token, we compute dot products between its query and all keys. High dot product means high relevance. We softmax these scores into attention weights, then sum the values accordingly. The result? Each token becomes a weighted blend of the entire sequence, dynamically informed by every other token. This is called self-attention. And here's the beautiful part: because it is all matrix multiplication, no loops, no sequential dependencies, your GPU processes thousands of tokens in a single parallel operation. A transformer is not just attention. It is layers of attention stacked with feed-forward networks, residual connections, and layer normalization. Multi-head attention runs several attention operations in parallel, each learning different relationship types. One head might track syntax, another semantics, another coreference. The original architecture combined an encoder stack with a decoder stack. BERT uses only the encoder for understanding. GPT uses only the decoder for generation. But the principle remains: self-attention lets the model build rich contextual representations without architectural bottlenecks. Add positional encodings so the model knows word order, and you have the foundation for every large language model, every AI chatbot, every code assistant you have ever used. The transformer did not just improve NLP benchmarks, it enabled scale. Because attention parallelizes, we could finally train on internet-scale data. Models went from millions to hundreds of billions of parameters, then trillions. This was simply not possible with sequential architectures. The transformer is also remarkably general. Vision transformers process images as patch sequences. Audio transformers transcribe speech. Protein transformers predict molecular structure. Multimodal models combine text, images, and code in a single architecture. One design pattern, every modality. So the next time you prompt an AI and it understands context from 3 paragraphs ago, remember, it is not magic. It is matrix multiplication at scale.